Now we're ready. All right, so which way do you want to solve this one? Do you want to solve it algebraically or do you want to solve it graphically? Graphically? Okay, let's solve this one graphically then. So, how are we going to solve this one graphically? There's two possible ways that we could solve it graphically. Talk me through the overall picture on how to do graphically. And then we'll do it. So how would we solve this one graphically before we actually go and do it? Let's plan our work. What do you got? Okay, so you're going to go left side as one function, right side as another function. Okay, and then when you get the graph, what would you be looking for? Okay, so then we find the intersection points, and then what would we be looking for? Where the absolute value one is. Where it's below the other one. So the tentative plan right here is we're going to have something, and we're going to actually do this here in a minute, but we're going to have a V, and then we're going to have a line going across it at 6. And so we're going to look for this stuff below that V. Okay? Just having a little plan of what we're actually going to do. Okay? Now, that's one way of doing it. Great way. Love it. You're probably already halfway done with it. Okay? What's the other way of doing this exact same problem graphically? Move that 6 over to the other side, or get it all on one side, and then instead of looking for the intersection points, what would I be looking for, Sam? I'd be looking for the zeros then. And again, it would be where I'm below the zeros. Okay? So there's two different ways of doing it. It all depends on how many functions you want to type into your calculator. Okay? So let's actually, now that we've planned our work, let's work our plan. Okay? So we go graph, and our first one is going to be the absolute value of x minus 5. Whoa, I missed the x part. Start over again. X minus 5. Why isn't that xing? X minus 5 and 4 on the bottom. Okay, so there's that one. Okay, and then my other one is 6. There's that one. So it looks like I'm going to have to zoom out. Okay, so now you can zoom out a couple of different ways. You could go into menu, window, and expand it and zoom it out that way. Or you can grab on to the axes here and pull it in. Okay, either way works for me. But you need to see both of those intersection points. Okay, now we can do menu, analyze, intersection twice, or let me show you another way of doing it too. We can go menu, I can go geometry, points and lines, and then I can go intersection points. But here now I have to choose the graphs that are the two functions. So I have to choose both of those functions by highlighting it and making it a little bolder, and then it does them both all at once. Okay? And I think you can do that with zeros too, provided you put in the function of 0, and then you can do intersections. Okay? So let's get that over there. Let's get this over here. Let's sure, and then I got to go over her. Okay, so less than or equal to 6, correct? So that interval would be what? Let's give our answer in interval notation. Less than or equal to 6. Bracket or parentheses? Bracket. First number? First number? Negative 19. Second number? 29. Bracket or parentheses? Bracket again. And there, ladies and gentlemen, is the solution to that absolute value. Okay? Questions on that? On this second one here, what I would like you to do is I would like you to try and solve it algebraically, okay? And then check it by solving it graphically. Okay? So try solving it algebraically first, and then check it. So, if I was to solve this one algebraically, the first thing that I would do, and granted, I'm a different breed of cat, okay? I would factor this side if it's factorable. And in fact, this side factors to be x minus 5 and x plus 2. Okay? Now, I'm going to find the zeros of that one by I'm going to say x minus 5 equals 0, so x equals 5, and x plus 2 equals 0, so x has got to be negative 2. So my function crosses the x-axis at negative 2 and positive 5. Okay? Now, knowing what I know about parabolas, okay, I know that this parabola opens up because it's got a positive a value. Okay? So that means that this parabola is going to go like that because it has a positive a value. So I want to know when it's greater than 0, so that's going to be from negative infinity up until negative 2, and then it goes negative until 5, and then it stays positive forever. Okay? Proving that now graphically, oops. Come on now. Pushing buttons here. X squared minus 3x minus 10 looks like that. I can zoom back out again. Maybe not. Whoa. Whoa. That's kind of cool. Okay. So there is 5. There is negative 2. And it's below it between them, okay, which means it's above it on the outside. Oops, wrong way. This way. That one. That one. Now here. Okay? Questions on that one? So we can solve things both algebraically and graphically. First objective, done. Second objective, 3-question formative. So let's get that 3-question formative out the way.